Hello friends, welcome to my new video on STADD Pro Connect edition. In this video we will learn to model and analyze a pre-stressed concrete beam. Please like, share and subscribe to my YouTube channel to learn STADD Pro Connect edition. Before going for modeling and analyzing a pre-stressed concrete beam, let us first see the problem statement. Here you can see we have taken a problem statement from a standard book of pre-stressed concrete. So we need to find the stresses at the extreme fibers of the mid-span section when the beam is supporting its own weight in addition to the live load of 6 kN per meter. And in the figure you can see we have the cross section of the beam, which is rectangular, of overall depth 300 mm and width 200 mm. Span of the beam is 6 meter, and we have 18 wires of pre-stressing cables, out of which 15 wires are located below the centroidal axis and 3 wires are located above the centroidal axis. Diameter of the wire is 5 mm and the eccentricity of the wire is also given, or we can say the location of the wire is also given. Now we will model this problem in our STADD Pro Connect edition, and we will see the result or the stresses that the STADD Pro is giving and what we have computed manually. So let us come back to this STADD Pro Connect edition. Here you can see this is the working interface of the STADD Pro Connect edition. As per previous practice, we have seen that whenever we want to create a new model, we will go to this tab, that is new tab. Let us click this first and we will give the file name. So let us give the file name as pre-stressed concrete beam, and we have to locate that where we want to save this file. So for that we will give our option. So let us click on this browse. So here we will click on desktop because I have created a folder STADD, and in the STADD I have created a folder named pre-stressed. So all the files as well as the supporting files will be stored in this folder. It is a very good practice because whenever you want to open that file later on, you can directly double click from that folder itself and that model will be opened. So let us give the direction of this folder to the STADD Pro, and we will again click on this configuration tab first. So let us click this configuration tab. Here base unit is metric and the global axis is in the Y up direction. So let us click on this OK, and after all these settings we will click on this create tab. So once you will click on this create tab, the STADD Pro working interface will open. So as per our problem statement, we have a beam of 6 meter span. So first we will create this beam having 2 nodes and the length of the beam is 6 meters. So for that, first we will create the node 1. So node 1 is generally taken as origin, so we will take x coordinate as origin. So write 0 in place of x and press enter. Y and z will be automatically taken as 0, and in x we will write 6, enter. Here you can see 2 nodes has been created. We can go to this view tab and we will see the front view. So let us click anywhere in this white screen and this will be highlighted. So here you can see this is the front view. So here the 2 nodes you can easily see. Now we will add beam from node 1 to node 2. For that we will again come back to this geometry tab. We will click on this add beam and we will click on the first node. We will go to the second node, and here a beam has been added from node 1 to node 2. Now we will go to this property tab and we will give the section property of this beam. For that we will click on this define, and in the define we will go to this rectangular section. Here our YD is 300 mm, so we will give 0.3 meter and ZD 0.2 meter, and the material is concrete. We will click on add, we will close. Here you can see this section has been added in the database. Now we will assign this section to this beam. For that we will use the assignment method. So first we will select this beam. So the best option is that you drag your mouse in such a way that entire beam is selected at one go. Release your mouse, this will be selected, and this option automatically gets highlighted that we need to assign to the selected beam, and this is also highlighted. We will click on this assign tab. STADD Pro will once ask you whether you want to assign. Yes, we want to assign. Here you can see the rectangle of section 30 into 20 has been added. Now we will go to the support tab. Currently there are no support in the database. We need to add the support. So the problem, we have a simply supported beam, so we will go to this tab and we will use this option fixed butt, and in the fixed butt we will release all other forces and moments except Fy. Roller support is used, fixed butt option is used to create roller support in STADD Pro. This has been discussed by me in my previous videos. You can go and visit and see those videos. You will understand why we are using this option fixed butt, and then we will click on add. Now this support has been added here. Let us first select this support, and we have to select these two nodes here. So we will use this tab, go to the node cursor, and once you will click this node cursor, only node will be selected. Now drag your mouse so that two nodes are selected at one go, and then use this method, that is assignment method, and we are using assign to the selected nodes. Click on assign. Software will ask you whether you want to assign. Yes, we want to assign, and here you can see the two roller support has been added in the beam nodes. Now we will go to the loading case. As per the problem statement, we have three different types of load. One is the live load, second is the dead load, and third is the pre-stressing force. Now in the problem and in the solution, we can see that this is the resultant stress diagram, and this resultant stress diagram is due to the self weight plus pre-stress plus live load. So in our STADD Pro model, we have to create the load case in such a way that all the three loads are taken simultaneously. So for that we will click this dead load, live load, and pre-stressed. So we have given a title here, and the loading type can be taken anything, whether it can be taken dead, low, or live. Let us take it as a live. Add, close. Now under this dead plus live and PSC, we will add all the three loads. So self weight, direction is global Y, factor is -1, add, and in the member load we will write uniform force, direct value is -6, and since this UDL is acting over the entire span, so for that D1, D2, D3 is 0, direction is global Y, add. And the third type of force is the pre-stressing force itself. So for that we will go to this option, that is pre-stress and the post-stress. Click over here. So in our problem we have pre-stress and the force. So for that we need to calculate the force. So here you can see in the problem we have altogether 18 wires of 5 mm dia. So the force has been calculated here. This is coming out to be 300 kilonewton. So we will directly give the value of 300 kilonewton in the STADD Pro, and eccentricity we need to calculate. So in order to simplify the analysis problem, the centroid of the pre-stressing force has been computed in this problem. It is coming out to be 100 mm from the bottom, and eccentricity is therefore calculated as 50 mm. So this eccentricity is constant throughout the length of the beam. So in that case we need to give the data in the STADD Pro. Here you can see in the STADD Pro we need the value of force and we need the value of eccentricity at the start of the beam, at the middle of the beam and at the end of the beam. So force is 300 kilonewton, and there is a sign convention of STADD Pro is that the eccentricity below the centroidal axis is taken as negative and above the centroidal axis it is taken as positive. So at the start it is minus 0.05 and in the middle it is also minus 0.05, at the end it is also minus 0.05. so because we have a straight cable having a constant eccentricity, so let us copy this and paste this at these two positions also. Click on add, close. So here you can see all the three types of forces or the loads has been added here. Now we need to assign this one by one to this beam because there is a question mark in front of everything. So let us click over here self weight, and now we will use this method, that is assign to view method, because currently we have only one beam and we need to assign this to all the loads. So for that we will use this method assign to view. First check this, then click on this self weight and click assign. So computer will ask you whether you want to assign, press yes. So this self weight has been added and question mark has been removed. Similarly, click on this option assign to view, use this live load, click here assign, yes. So live load has been added. Again assignment method is assign to view, pre-stress force and assign, yes. So now all the three types of load has been assigned and all the question mark has been removed. Now we will go to the analysis part. Here we need to define our commands. So let us click define commands, add no print option, close, and in the post analysis command go to define command, click on analysis result, add, close. So these two commands has been added. Now we will click on this run analysis. Computer will ask you to save the structure, save, and the analysis will be done by the software. So currently we have 0 error, 4 warning, 4 notes. Close this tab first and click on the post processing tab. So in the post processing tab, as I have discussed earlier in my previous videos, whenever all types of loads should be in the selected window. Here by default the load is already been selected. If somehow these loads are not selected or it is available in the available window, make sure that these loads are in the selected window by clicking these arrows. Click on apply, OK. So in the post processing, directly come to this beam results. So in the beam result, now we will click on this layout option. Here in the layout option, click on this beam stress layout, and in the beam stress layout, if you double click this beam or click this beam here you can see this is the stress diagram of the beam stresses. Now we want to know the beam stresses at the mid span section. So for that we will give this distance to 3 meter because our overall length is 6 meters. So at the mid span section we need to calculate the stresses at the extreme fiber. So for that distance is 3 meter, and here you can see this is the stresses that we are getting at the topmost fiber and at the bottommost fiber, and these stresses have been computed by the STADD software directly. So at the top we are getting 11.121 Newton per mm square, at the bottom we are getting minus 1.121 Newton per mm square. Now this minus sign signifying that we are getting a tensile stress at the bottom of the beam, whereas at the top of the beam we are getting compressive stress. Now if you move this slide, you can get the stresses at different cross section. So let us write here 3. So we can compare these results with the results that had been done in the book, and here you can see we are getting 11.16 and at the bottom we are getting minus 1.16. So this is the resultant stress diagram, and this is the stress contours which has been computed by the software. And you can close this tab, and here you can see for other cross section we can find the stresses, because the moment is of the beam, and the stresses due to the moment of the beam depends on the span of the beam. So if you move from node, move away from the node, the moment, the value of the moment will change, and correspondingly the stresses will change. So I hope you all have understood how to model and analyze the structure in STADD Pro Connect Edition. And this is a pre-stressed concrete beam, and you can also solve various types of problems, and you can interpret your results.